Okay, great. So the agenda for today's session is we're gonna focus on machine learning and how to do all of what you've done in class in code. There is one additional thing that I want to cover, and that's logistic regression. आप लोग इसको theoretical level पे cover करेंगे in the upcoming lectures. But since some students are going to be needing this for their projects, which are due soon, I thought to add this over here as well. This is code that should help you implement your models or use your models and your from your libraries in code for your projects. So largely this should help you with that. Okay. First we look at data preparation. We're going to follow through some steps and look at different kinds of data. One technique that we studied in class is the concept of normalization. Normalization is, well, what it does is कि it ensures कि आपके एक feature की सारी values आ जाएं within the range of 0 and 1. This is the formula that you apply. This is also called min-max scaling. एक value की आप normalized value calculate करते हैं by subtracting that value from the minimum and dividing that by the range, which is the maximum minus the minimum. So essentially what this does is कि जो आपके उस column की smallest value है, it becomes 0 and the largest value shall correspond to 1. Why is this so important though? It is really important you do this with numerical features, and it's really important because otherwise some of your numerical features may dominate over others. For instance, if you have a data set जिसमें आपके पास age है and आपके पास salary है, so the typical range for age could be from perhaps 18 or 20 till 70, the age of retirement, or maybe 50. But salaries would have a much higher, much broader range. In fact, they could start at 1 lakh and end at maybe 15 or 20 lakh. So as a result, जो salary है, that would dominate over the feature of age in your data set, even though there is no reason for you to give more importance to one than the other by default. That is why you bring them to the same scale. I would want to normalize salaries and I would want to normalize ages of people before passing this data to a machine learning model. Okay, so let's look at one problem. I have created a data frame over here. Age and income ka hi data frame hai. You just have 5 rows in this data frame. I am going to perform min-max scaling simply by what I've done over here is essentially कि मैंने minimum value ले ली है age की. For your information, I'm just gonna copy paste this here as well. Okay, well, this isn't working. Regardless, I will just scroll up then. So मैंने DF के age column में से minimum value निकाल ली and maximum value निकाल ली. Then I know that in order to create a new column, this is what I do. So what I'm doing is कि मैं current age minus minimum age कर रही हूँ, which I had already stored in a variable over here, and then I divide that by the maximum age minus the minimum age, and that will give me the normalized scale value for age. This is exactly the formula that I've applied essentially. And then I do the same for income. As a result, this is what my data frame looks like. Alternatively, अगर मैं इसको इस तरह कर लेती, तो it would have just directly stored this in my original columns. Alright, but for now, I'm not gonna do that for your information. Let's see. So essentially, age की 0.0 value आई है against the age of 25, which is the youngest individual in my data set right now. Similarly, the maximum value 1.0 is against the age of 45, which is the oldest individual in my data set. I would want to show you now how you can do this using a built-in scaler in your sklearn library. sklearn को हम use करते हैं for your machine learning tasks essentially. So I will show you how to do this like that as well, क्योंकि you don't always need to use pandas to apply every single formula of this sort. So this is what I've imported from sklearn.preprocessing import min max scalar, and min max jo hai, that is essentially normalization. And I'm reading uh, from a CSV into my data frame life expectancy data, which we have used in some of our previous tutorials as well. So anyway, this is the data set. इसके numerical features के ऊपर मैं min max scaling कर सकती हूँ. So this is what I'm doing. I am extracting the values from life expectancy and I am storing them into a array. Once I have obtained these values, so this is just to actually show you कि आप किन values के ऊपर इसको run करते हैं. And now I have to initialize a scalar. So scalar equals min max scalar. ये initialize हो गया. And then this is the command that I call on that scalar dot fit transform. एंड फिट ट्रांसफॉर्म को मैं यही डेटा पास कर रही हूँ डॉट वैल्यूज करके. दैट्स व्हाई आई एम शोइंग यू व्हाट डॉट वैल्यूज गिव यू. बट आई रीशेप दिस डेटा टू मेक इट वर्टिकल बिफोर running the function because that is just the requirement of the function. And this is what it comes out to be. So I've only done this for one column, but you can do the same for all numerical columns as well. Are there any questions?
Nothing so far. Thank you.
Sorry, what?
No questions. Nothing.
Oh, okay, okay, all right, great. So let's move to the next version of this notebook. Isme we're gonna look at standardization. This is essentially another normalization technique. It's called Z-score normalization as well. Standardization का ये formula है. You take every single value. This is how you calculate its Z-score. That given value minus the mean of that column divided by the standard deviation of that column. इससे values एक fixed range में नहीं आती, but इससे values arrange हो जाती हैं in such a manner that the column has a mean of 0 and a standard deviation of 1. Why do we need to use this as opposed to min-max scaling? When is this more helpful to us? So the thing is that standardization is more robust to outliers as compared to normalization or min-max scaling. And that is evidently because min-max scaling के अंदर हम minimum और maximum values को subtract कर रहे हैं, हम उस range को use करते हैं. So अगर मेरे पास age का data था, for instance, and I had people of ages 25, 30, 35, 40, and then due to some logging error, perhaps I had a value of 1000, which is really practically impossible. So 1000 किसी की age नहीं हो सकती. It must have been an error. But during the process of normalization using min-max scaling, वो उस वैल्यू को एज एक मैक्सिमम पिक करेगा. एंड जब आप उस वैल्यू को यूज करके बाकी नॉर्मलाइज करेंगे वैल्यूज को, तो देन व्हाट विल हैपन इज कि जो 25, 30, 45 ये वाली एजेस हैं, they're going to be extremely close to zero, like 0.0001 or so. And जो आपकी larger value है, that will be exactly 1, which is why standardization is more robust to outliers. So it really depends on the nature of your data. But let's try this out on the same data. So once again, I use my age column, I get its mean. I also get its standard deviation this time, और मैंने इसको calculate कर लिया. DF age minus mean age divided by the standard deviation of age. And then I do the same thing for income. And this is what my data frame looks like. So, what do the negative values represent in this scenario, and what do the positive values represent? So, अगर आपकी value, अगर आपका z score positive आता है, if it's greater than 0, that means that the value at that index was essentially greater than the mean of that column. अगर ये 0 से छोटा आता है, if it's negative, so then that means कि the value was in fact smaller than the mean, it was lower than the mean. If it's exactly 0.0, so that just happened to be the mean of the column. And in values का mean age के column में 35 ही निकलता है, which is why 35 का z score is actually 0. If you look at the formula, you're doing the current value minus the mean. So this will obviously give you 0 if the current value is the mean. Similarly, these two values that are negative, 35, sorry, 30 and 25, both of them are smaller than the mean, and 40 and 45 are both, in fact, greater than the mean. The same goes around for income. Now I will show you how you can do this using a standard scaler from the sklearn library, and पहले मैंने min max scaler import किया था. Now I'm importing a standard scaler. So once again, I'm going to read the same data. Once again, I'm going to extract the values of life expectancy. I'm going to reshape those values, and I run the exact same command, scalar.fit transform, except कि this time scalar को initialize करते हुए मैंने min max scalar नहीं लिखा, standard scalar लिखा है. And this is what my values look like as a result. Are there any questions?
No.
All right, great. Let's move on then. Next, we are going to look at linear regression. हम linear regression देखेंगे, simple, multiple linear regression. Then we're going to look at logistic regression in code as well. We're going to do all of these in code essentially. So the library that I'm using right now is stats model. आप stats model भी use कर सकते हैं, आप sklearn भी use कर सकते हैं. You can use a combination of these two as well. So right now I'm using stats model for my model, and I'm using sklearn for, well, I'm importing a few more functions. I will show you along the way. So these are the necessary imports. This is a data frame that I will be working with. अगर हम ये पूरा data frame display कर लें, yeah, so essentially I have like 39 values over here. This is a data frame of student scores, their score in the midterm exam, in the final exam, and then overall their aggregate in the course, which would obviously include other components of the course as well. लेकिन डेटा सेट में आपके पास मिड है, फाइनल है एंड ओवरऑल स्कोर है. सो व्हाट आई वांट टू डू इज आई एसेंशियली वांट टू सी कि ये ओवरऑल स्कोर स्टूडेंट्स का प्रिडिक्ट किया जा सकता है कि नहीं, using their performance in their midterm and their final exams. All right, this is one of the things that you do during EDA. So just to display the correlation matrix between the three variables for your information, you use the CORR function for this. um one wali values हैं obviously against the columns against themselves at the diagonal, and I can see that there are very high correlations between all other columns as well, which means that the midterm exam score and the final exam scores should logically be very good predictors of the overall score of a student in the course, which is very intuitive as well actually. Okay, so we're gonna follow a bunch of steps. I will walk you through these steps. मैं अपने डेटा सेट को स्प्लिट कर रही हूँ. What I want to do is कि I want to separate out some data into a testing set, and I want to separate out some data into a training set. ट्रेनिंग सेट वो है जिसके ऊपर मैं अपने मॉडल को फिट करूंगी, एंड टेस्टिंग सेट वो है जिसके ऊपर मैं अपने मॉडल को इवेल्युएट करूंगी essentially. The function that I'm using is train underscore test underscore split, which is the function that I have imported from sklearn.model selection right over here. So आप इस function को use करते हैं. इसके parameters में मैंने क्या दिया है? I have given the data frame, I have given the test size, and test size equals 0.4 का मतलब ये है कि I want 40% of my rows at random to be put into my test data. And random state is just a seed that you use for reproducibility. आप इसको for now ना भी use करें तो it's fine. For your projects, of course, your code should be reproducible actually. So this function is now going to split my data frame into two data frames and return both of those data frames to me in the given order, train and test. So उन्हें मैं receive कर रही हूँ here. So if I run this, this is what it looks like. See, at random, it put 40% of my rows in the test set and 60% of my rows in the train set. ये indexes से हमें पता चल रहा है कि this was a random function that was applied over here. I could also change this proportion. Now I only have 5% of my data in the test set. Okay, so now that I have my data, what I will do is कि मैंने अपने डेटा को अब split करना है into my features and my variable that I'm trying to predict. So one thing at a time, train data mid and final. अगर हम सिर्फ इस वाली command को pick कर लें, तो this is what it gives us. Essentially a data frame जिसके सिर्फ ये दोनों columns selected हैं, because these are my two columns that I want to use as features. That's why I'm storing them in xtrain. And sm is, well, ये starts model library को मैंने import किया था, starts model का API as sm. Let's look at this further. Hold on, where was I at? या सो मैंने इसको ट्रेन डेटा पास किया, sm लाइब्रेरी का एक फंक्शन मैंने कॉल किया है add constant, which is just gonna add a, well, you have to manually do this in stats model. You don't have to do it manually in sklearn, but I will show you in sklearn as well after this, so that you're free to use whatever. Okay, so ये constant add करता है as an intercept in regression. And similarly, y train में मैंने वो variable store कर लिया है. Now this is just a series train data overall. So वो variable मैंने store कर लिया है, which is essentially my target variable, which I want to predict. And I do the same with the test data as well. Now I'm gonna run my simple linear regression model. So I am gonna start with a simple model that will use only one predictor variable. ये सिर्फ final exam score use करेगा in order to predict the overall score, and it uses OLS by default. Sorry, I have called OLS over here, so it's gonna use OLS. आप formula specify करते हैं. This is the format that is expected for this library. So I've written overall, which is the variable that I'm trying to predict. And मैंने उसके आगे सिर्फ final लिखा है. So final is the only score that I'm gonna use in order to predict OLS. And then I specify that the data is my training data. And I run the dot fit command, which what it does is कि ये मेरे model को fit करती है to my data. So this is the command that is used for training. So that's what I'm doing here. अब ये train data में से automatically final exam score निकाल लेता है as your predictor, and overall निकाल लेता है as your target variable. So I have set my model over here. If with this one command, मेरा model initialize हुआ है and मेरा model train हो गया. It has fitted to my train data. Now I would want to predict a couple of values for my test set. So this is what I do. Simple model dot, it's as simple as it seems, dot predict, a predict command. And I will pass my test data to my predict command. And then वो इसी model में सिर्फ यहाँ पे test data दे देगा and उसके against predictions obtain करेगा. So that's why prediction simple, and well, I will use these later as well actually. And then I can, for your information, run a dot summary command, which gives me a summary of my model. And this is what it looks like. Well, actually, इसने मुझे date और timestamps भी दिए हैं. इसने मुझे model की type बताई है, and it has given me a bunch of stuff like R squared, adjusted R squared, etc. Now, if I want to if I want to find the evaluation results, yes, Taha, please go on.
I just wanted to ask, are there any other ways in Python where we can use any other technique rather than OLS?
हाँ, you can do that. You can absolutely do that. I will share code उसके ऊपर भी.
And in what scenarios techniques other than OLS are relevant?
We will get to it. I
Okay,
will show you a couple of things that you can do.
fine.
Okay, all right. Moving on. So, जब आपने evaluation matrix देखने हैं, so what I'm doing is, well, this is what you've studied. You've studied MAE, MSE, R squared loss. So I'm calculating MSE over here. जिसके लिए again I have just imported a function over here from sklearn.matrix import mean squared error and R2 score. So ये दो functions हैं, जब मैं इन्हें use करूंगी तो ये मुझे ये scores खुद ही calculate करके दे देंगे essentially. Yeah, here we go. So this is what I give it. I give it y test, and y test is what those are my ground truths, and I give it y predictions, which are what the predictions of my model. And I pass that to my mean squared error function. Similarly, R2 score को भी मैंने यही दो चीजें पास की हैं, and ये इसने मुझे calculate करके दे दिया, so I don't have to do those myself either. Okay. On that note, moving on towards multiple linear regression. Well, the difference is कि simple linear regression में हम use कर रहे थे सिर्फ एक predictor variable to get the result. In multiple linear regression, you're using a combination of features to get the same result. So you're training a multiple linear regression model. It uses these two features. Obviously, we had only these two features available, the mid plus the final, and well, everything else is more or less going to be the same. So once again, I've run the dot fit command. Once again, I am using, so मैंने इस model का सिर्फ name change कर दिया. For this model, I'm using the dot predict command, giving it the test data and then running it. Then I am going to evaluate my model once again. And this is what the result comes out to be. So one important thing to be mindful of is that increasing the number of variables is not essentially always going to increase the performance of your model, or it's not always going to improve the performance of your model, which is why for your project I would encourage you to try out multiple models, try out combinations of different features, and try out combinations of various hyperparameters to see what works best for you. I'm going to pause over here for 1 to 2 minutes on account of the azan. You can go through this in the meantime. Okay, are there any questions? Can you hear me?
Yes, I can hear you, but there was a bit of
There was a what?
lag,
Oh,
lag
okay,
in your
all
voice.
right. Well, if it happens again, just let me know. Okay, before we move on इससे आगे, I will clarify over here ताहा कि हमने आपको cover करवाया है ordinary least squares OLS because it's easy to interpret in the future though, but I think we also did touch this in the recent lecture. You have also covered slash will also cover ridge regression. You will also cover lasso regression. So आप regularized regression को cover करते हैं. For now, for simplicity, this is what I'm going to focus on, but I will provide you materials on those as well. If you get the hang of one, you will be able to do the rest as well anyway. All right?
Fine, thank you.
Okay, you're welcome. Are there any other questions?
Just a bit of clarification on the other regressions that you mentioned. is there just a difference in interpretation, or the computations are also different when it comes to estimating different forms
हाँ,
of?
इसमें इसमें डेफिनेटली कंप्यूटेशंस भी आपकी डिफरेंट हैं.
Fine.
जो
And
इसके बाद आप लासो एंड रिज रिग्रेशन पढ़ते हैं. आई थिंक यू ऑलरेडी टच्ड एट लीस्ट वन ऑफ देम परहैप्स और परहैप्स बोथ ऑफ देम. तो उसके अंदर यू ऐड अ पेनल्टी टर्म एज वेल.
fine.
And essentially, that penalty term is what impacts your model weights when they are being updated. So, आपकी computation उसकी slightly different होती है. You should be able to do that computation on paper as well.
Fine. Fine. Thank you.
You're very welcome. All right, moving on. So, like I told you guys, and personally, I prefer sklearn as well. So, I'm going to walk you over the exact same scenario, but using sklearn now. So this was our data set. We're working with the exact same data set. We've already looked at the correlation matrix. I'm just making one plot over here to show you that this is an important part of the process as well. हमने ये पहले नहीं देखा था. Which essentially it just emphasizes that there does feel like a strong correlation exists between mid and overall score as well as final and overall score. Anyway, so we're gonna follow more or less the same series of steps. You define the features and the target. Features X में store कर रहे हैं हम और target को Y में store कर रहे हैं. One thing that you will notice over here is that instead of just the data frames, I use dot values. So let's see what X gives us. See what it does is कि वो उसको array में डाल देता है जिस तरह हमने normalization और standardization में भी देखा था. Y के लिए भी it's gonna be an array because this is the format that your model is expecting then. And then step two, you split the data into your training and testing sets. Okay, so मैंने train test split का ही function use किया है, which is a function of sklearn.preprocessing. The difference is कि मैंने x और y को अलग अलग इसमें specify कर दिया है instead of giving it just one data frame, and this function will run fine just like this as well. ये इस तरह भी आपको जो है वो दे देगा split करके x और y को against the corresponding rows ही split करेगा. Once again, I've specified the test size. I have specified the test size as 0.2 right now. In step three, you are going to scale the data. Now I am doing a step of data preparation before I'm moving on to my module. So what I'm doing is कि मैं normalization के लिए I'm doing z-score normalization. I'm not doing min-max scaling, and we've already seen how this works. So I've initialized my scaler and I have called the command dot fit transform on my train data and dot transform on my test data. The reason for doing this is आप fit के साथ command call करते हैं when you're working with your training data because your scalar is also fitting to your training data. To your testing data, you don't use the fit transform command to fit. You only use the transform command because वो scalar अब fit कर चुका है. उसने जो भी mean value लेनी थी, standard deviation लेनी थी, वो उसने x train में से ले लिया. अब वो y टेस्ट के अंदर सॉरी x टेस्ट के अंदर उसको as it is सिर्फ यूज करेगा. Otherwise, there could be a problem of data leakage. I could be passing on information from my train set to my test set. So anyway, now I have calculated my scaled features. In step four, I'm going to define a model. I am using multiple linear regression now. I am not using just one predictor, but मैं दोनों variables को as predictors use कर रही हूँ. So it uses OLS by default again. So model equals linear regression. This is where I imported linear regression from sklearn.linear model. Okay, so इसको मैंने initialize कर लिया. In step 5, I'm going to train my define model, which is simple enough. You have a command dot fit which you call on your model. Dot fit को आप दो चीजें pass करते हैं. You pass to it your training features and your training outcomes. Sorry, your training expected outcomes. Okay. In step 6, I would want to make predictions on my test set, for which the command is once again simple enough, model.predict. And predict को मैं सिर्फ x test scaled pass कर रही हूँ because I only want to give it the features. Obviously, I don't want to give it the ground truths because I want to see कि वो क्या predictions देता है. And it's returning to me a set of predictions which I'm then storing in y predictions. We can also take a quick look at what Y predictions looks like as well. So this is what it looks like. ये भी array format में है. अब अगर मैं compare करूँ इसको Y test को Y prediction से, तो essentially I can, well, they actually seem fairly close as well. So now I can calculate my evaluation matrix accordingly. In step 7 and my final step, I am evaluating my model. These are the functions that we've seen before and we're using them as they are. And this is what the output comes out to be. Are there any questions before we move on?
No questions.
Okay, all right, great. Let's move on then. So we're going to cover logistic regression. Logistic regression you have not covered in class yet, I know that. You're going to cover it in this week, inshallah. At the same time, for those students जो classification के tasks कर रहे हैं, so if you're not doing classification and you're just predicting numerical continuous values, then the regression techniques that we have looked at previously should work for you for your project. You're welcome to explore others as well, like students work करते हैं with other models as well, like decision trees, random forests, even neural networks. But for the scope of this course, this is what we teach you. For classification tasks, जहाँ आपने एक class predict करनी है, for instance, female versus male, cat versus dog, malignant versus benign, वहां पे you are gonna need logistic regression. So to give you code to help you get started, I will walk you over the evaluation matrix in some detail only for now. So once again, I'm using sklearn for this. Um, I am generating some data right now. I'm not gonna walk you over the data generating algorithm because it doesn't matter. Anyway, मैंने 500 samples generate किए हैं. This is what's available to me. I have the age of an individual, I have their gender, their education, their marital status, and a value of purchased. So this data set is this is customer data. It's for a certain product or whatever बेशक एक स्टोर है जहाँ पे एक पर्सन ने कुछ परचेज किया या नहीं किया, and you're trying to see if these four characteristics of a person are enough to give you any information about their purchasing behavior or not. So it's a simple enough problem. Since हम जो चीज predict कर रहे हैं वो एक class है, the purchase class, either purchased is 0 or it's 1, either an individual purchased something or they did not. So hence it is classification, hence we're gonna use logistic regression. Okay, so we're gonna walk over a series of steps. First, you define your features and your target. अब मैंने इसको simpler तरीके से define किया है. df dot drop purchased, access equals 1, access equals 1. We all know what that means by now. I want to iterate over my columns instead. उन columns में से मैंने purchased को drop कर दिया है, which leaves everything else in X, which are my features. And well, purchased को फिर मैंने Y में store कर लिया है. So this is what X looks like. At the same time, मैं इन चार columns की array भी pass कर सकती थी. And evidently, this is what Y looks like. Okay, so that was step 1. Step 2 is a little more extensive, and this is something that we expect you to be very mindful of as well, क्योंकि अब हम data preparation की तरफ आ गए हैं. इससे पिछली जो examples हमने देखी उसमें data preparation didn't really require a series of steps. हमने सिर्फ normalization की, but that's what you do with numerical values, right? When your values are not numerical, then you have to look at other techniques as well. And these I believed are covered in class as well. So anyway, आप हर type के variable को import करते हैं one at a time. um I just want to quickly show you कि कौन कौन से हमारे पास variables available. Sorry, it was capital X. There we go. So I have age, gender, education, and marital status. Age का column numeric है, which means कि age के column के ऊपर मैं standardization या मैं min max scaling कर सकती हूँ, which is what I'm doing with age, and we know how this works. So scalar equals standard scalar, and then मैंने ये काम age के column के लिए कर लिया to bring the age within the range of 0 to 1. Hence, I have prepared my age column. All right, this is what it looks like. अब मैंने अपने बाकी columns को भी देखना है. I have gender, I have education, and I have marital status. So you have different encoding schemes available for these, in fact. Let's see, what can we begin with? You could begin with education. Education के अंदर अगर मैं देखूं, so let's see, education dot value counts. All right. I hope everyone is familiar with this. ये आप command use करते हैं to see के कौन सी unique values exist करती हैं for a given column in your data set, and हर unique value के against आपके पास well कितना count है essentially. Hold on. Okay. Right. So I have bachelor's, high school, master's, and PhD. There is a certain order to my values, and I can identify that order based on my domain knowledge. So I know okay, high school evidently goes before bachelor's, bachelor's goes after high school, master's goes after bachelor's, and then PhD comes last. I know कि ये order है, which means now obviously my model cannot understand all of these things. My model can understand numbers. So I have to find a way to turn these into a numerical representation and then give those to my model essentially. अगर मैं इन्हें इस तरह encode करूं तो it should suffice actually. अगर मैं इन्हें इस order में encode करूं. This, by the way, is an example of ordinal data. And ordinal data के ऊपर आप ordinal encoding कर सकते हैं just like this. Just 1, 2, 3, 4. I can give it these values. So this is what I'm gonna do. I have created a function for this education order. This is how we use dot apply in pandas. I hope you're all well familiar with this, in fact. So इसको value pass हो रही है. If the value is high school, I return 0. If it's bachelor's, I return 1. If it's master's, I return 2. Else, if it's PhD, I return 3. So this is how I am encoding my education का column. इस पे मैं ये function apply कर रही हूँ. As a result, if I look at my data frame, this is what it looks like now, education encoded. So मैंने इसको एक नए column में रखा just to show you. Eventually, I could have just stored it in this column, overwritten this, or I can just drop this column later. Which brings me to my next concern then. और हमने क्या encode करना है? We have gender and we have marital status. So if I check for gender now, dot value counts, this is what it looks like. मेरे पास ये तीन unique genders हैं, but based on no domain knowledge whatsoever, can I put them in a certain order? There is no way that a male is bigger than a female and a female is bigger than another. Which means कि अगर मैं इनको इस तरह से encode कर दूं, तो इसकी ये implication है कि मेरा model इसको interpret करेगा as if this is somehow the smallest value of this column and this is somehow the biggest value of this column. It will not give my model the meaningful information that I'm trying to give it. I don't want one value to dominate over the other. They are in no specific order. And जब इस तरह होता है when your data is, and this is your categorical data essentially, you have categories. Whenever you have categorical data available, तो आप ऐसा करते हैं कि you sorry sorry, my bad. Whenever you have categorical data or you have nominal data available, I think कि this is not your categorical data, this is your nominal data. Categorical data जो है उसमें आपके पास categories like A, B, C Anyway, so if I give it in this way, so I cannot set a specific order. Whenever you have data of this sort, both of those, so what you will do is कि आप उस पे categorical encoding या one hot encoding करते हैं. Those are used interchangeably. I hope that that doesn't confuse you. This is what one hot encoding does for me. मैं तीन new columns create कर लूंगी. So gender male, similarly gender female, and lastly, gender others. Okay, so I will do this. When I create these two new columns, तो हर row के against if the value was male, तो मैं इसको 1 set कर दूंगी and मैं इन दोनों को 0 set कर दूंगी. If the value was female, तो मैं इसको 0 set कर दूंगी और इन दोनों को मैं 1 set कर दूंगी. The thing about doing this is कि in no way am I giving my model any information about an order that obviously does not exist for this column. But at the same time, I'm splitting this into three features and I am telling my model कि for one individual it will know कि अच्छा इसकी gender male value true है या नहीं है, इसकी gender female value true है या नहीं है, and इसकी gender others value true है या नहीं है. So this is how one part encoding works. Now to show you it in code, this is what I do. ये pandas का ही function है get dummies, and get dummies is going to do one hot encoding for you basically. आप इसको column pass करते हैं, you pass it the prefix, but passing it the prefix is not important. I will show you what it does essentially. अगर मैं इन्हें observe करूं, so this is what it comes out to be. I am just gonna remove this from here for now. Okay, so this is what happened. So this is the kind of thing that I told you. So मैंने जो prefix specify किया है, इसने उसको follow किया है. अगर मैं GEN specify करती, तो ये उसको follow करता. अगर मैं prefix specify ही ना करती, in fact, so it would have just done that. So this is really up to you. The other thing that I'm specifying, however, is important. Drop first equals true. जो उसको पहला इंस्टेंस मिलता है जेंडर का, वो उस एक जेंडर के कॉलम को ड्रॉप कर देता है. Why do we need to do this? We need to do this because if we don't, then my columns are gonna be linear combinations of the others. I'll tell you what that means. अगर मैं आपको एक इंडिविजुअल के लिए जेंडर फीमेल की वैल्यू बता दूं कि वो फॉल्स है, तो यू विल बी सॉरी, अगर मैं बता दूं कि ये ट्रू है, तो यू विल बी एबल टू टेल मी कि ओके दैट मीन्स दैट जेंडर मेल एंड जेंडर अदर मस्ट बोथ बी फॉल्स. Similarly, अगर मैं आपको बता दूं कि this is false and gender other is false, तो you will be able to tell me कि okay, then gender male must be true. One column should not be a linear combination of your other columns when you're passing that data to an ML model. In order to remove this problem of multi-collinearity, you add this command and you drop one of those columns, which still reserves your information. You are still giving the model the information that it needs while ensuring that no column is a linear combination of the other ones. So this is why I do that. Anyway, I have done this for gender and I've done the same for marital status because there is no inherent order that has to be followed for marital status either. So these are the steps that I followed. बहुत carefully you have to weigh कि आपने हर column को कैसे prepare करना है. And I've prepared all of that. And then I have prepared all of that. I've put it into one final data frame. Now, this is the kind of data, these are all numbers basically, true, false, be zero ones here. This is the kind of data that my model can interpret essentially. मैंने ये step repeat किया है now because we hadn't prepared our data as yet. So instead of running on X and Y separately, I've just ran on data frame. So steps 1 and 3 could be, you could do them in either way. Once again, I have repeated this over here. I have separated out my data into my prepared features and my target variable. Then I have used my split function to split my data into a train test. And जिस तरह मैंने इसको एक data frame pass किया था, once again I've just passed it x and y and I've received it in x train, x test, y train and y test. Which takes me to step 4. Now you're going to want to define a model. So this is the model that I've defined, logistic regression. This is where the model is coming from sklearn.linear model. I have imported this. So मैंने इसको define कर लिया. It's also using OLS. Now, in order to train my model, everything else is pretty much the same. Model.fit, I give it x train and I give it y train. Step 6, model.predict, I give it x test only to get the predictions. So I store that in y predictions. This is what y predictions would look like, by the way. So my focus is not how logistic regression works, क्योंकि उसको आप in theory cover करेंगे in your lecture. What you need to know is कि this is predicting 0, 1 values. ये classification कर रहा है. Essentially predict ये भी एक numerical continuous value ही करता है, because that's how regression works in general. It predicts numbers and then वो उन numbers के ऊपर एक threshold लगा देता है. जैसे if the numbers are from a range of 0 to 1, well actually they are going to be in that range, but I'm not going to get into why. तो वो 0.5 का अगर थ्रेशहोल्ड लगाएगा तो व्हाट इट विल डू इज कि जो भी वैल्यू 0.5 से बड़ी है वो उसको क्लास 1 का लेबल दे देगा, जो 0.5 से छोटी है उसको वो क्लास 0 का लेबल दे देगा. दैट्स हाउ इट इज डूइंग क्लासिफिकेशन via regression. So this is what y predicted looks like. Okay, so one more thing. अगर मैं y टेस्ट आपको दिखाऊं, so this is what that looked like as well. वो भी 0, 1 values थी. तो अब मैं देख सकती हूँ कि कितनी correct है. I can calculate different matrix. For instance, I calculate the accuracy, and that comes out to be 91%, which is really high. What accuracy is doing for me is कि it's just telling me the number of values correctly predicted divided by the total number of values. जैसे अगर टेस्ट सेट में मेरे पास 100 वैल्यूज थी तो उन 100 में से 91 उसने करेक्टली प्रिडिक्ट करनी है. दिस इज व्हाट दैट मींस. Then to quickly show you that there are other matrix that you can calculate as well, I've imported these other matrix over here from sklearn. Import, well, accuracy, precision, recall, F1, and then I'm also going to show you a confusion matrix and what a classification report looks like, but this will be reiterated in class later as well. You should know how to compute these yourself as well. But anyway, as far as this is concerned in code, आपने एक एक function उनमें से call किया है. These are different metrics that tell you about the performance of your model. And आप उन सब metrics को y test और y prediction ही pass कर रहे हैं. This zero division thing, well, you can ignore it for now because I'm not going to give you the formula for precision. When you cover it in class, this will be more clear to you. But for now, we can see that सारे ही matrix जो हैं, their values have been predicted as fairly high. I do want to show you a confusion matrix though. This is what a confusion matrix looks like. So, इसको हम थोड़े से बेहतर व्यू में देख लेते हैं. ये function भी मैंने ऊपर import किया था sklearn से ही, and इसको मैं y test और y predictions ही pass कर रही हूँ. But using matplotlib, I can just generate a better view of this matrix. So this is how I can explain it to you and how it works. You can use this code. I've given it to you for your information. आप इसमें plt.title लिखें तो you can add a title as well. ये जो 50 का नंबर है, if you look at it, तो यहाँ पे लिखा हुआ है on the y-axis you have true label, on the x-axis you have predicted label. 50 के अगेंस्ट यहाँ पे not purchased लिखा हुआ है, यहाँ 0, और predicted label भी not purchased है. So there are 50 values, 50 data points where the ground truth was 0, which is not purchased, and my model correctly predicted them as 0. 41 देखते हैं. 41 values are such that their true label was 1, that means purchased, and my model correctly predicted them as purchased. सो ये जो जीरो है जो करेक्टली प्रिडिक्टेड था एज जीरो, 50 वैल्यूज हैं जिसकी दीज आर कॉल्ड योर ट्रू नेगेटिव्स। 41 जिनकी ग्राउंड ट्रूथ भी वन थी और मेरे मॉडल ने भी उन्हें एज वन प्रिडिक्ट किया, दीज आर कॉल्ड योर ट्रू पॉजिटिव्स। Then, if you look at this value of 4, इनकी ground truth 1 थी, but my model incorrectly predicted them as 0. So these values actually refer to your false negative because my model falsely predicted them as negative, even though they were actually positive. That's why they are called false negatives. Similarly, ये जो 5 की value है, इनकी ground truth was 0, but my model accidentally predicted them as 1, which is why they are called false positives. So I have 5 false positives in my result. One last thing, you can use a classification report function as well, जो मैंने ऊपर import किया था. And instead of computing each matrix separately, ये आपको automatically इनकी report दे देता है. It also gives you a weighted and a micro average per class as well, but we're not gonna go into this depth right now. This is where it gives you the accuracy as well. यहाँ पे आपको ये data points दे रहा है कितने थे एक class के ground truth में, and this is the total number of data points. Okay, are there any questions?
No.
All right, that's gonna be all from my side for today then. Thank you, Allah Hafiz.
Thank you, Allah.